Hi class, alright, so this is Unit 2, and this will be actually Day 7 and Day 8 kind of together. They go nicely together. So we have one learning target number 9, and it says that I can describe and graph the transformations of a function given its parent graphs, okay? So we're probably going to use the app Desmos that we told you to download, so make sure you have that next to you. So let's see. We have a function, all these different types of transformation. That's a new word for us, right? We're going to be transforming, just like the movie, transformations, right? We're going to be transforming them, okay, or equations. So first off, it talks about this vertical translation. Translation is just a fancy way of saying slide, sliding up and down because it says a vertical. So we're going to be vertical shift up and down. So let's think, if it's going to be a positive C, that means I'm going to move it upward. And if it's going to be a minus C at the end, I'm going to move it down. If I give you an equation and you have a number out in front, that's a stretch. And the way I remember this is in the beginning of a day, in the beginning, right, I like to stretch. So all my stretches are in the front. So it's telling us if you have that number and the absolute value of it, so that means make it positive if it's not, and it's bigger than 1, it's going to be steeper. So that means if something is steeper, it's narrow because it's going up quicker and quicker. If the number A is between 0 and 1, so like a fraction, right? And we make it into a positive fraction. If it's not already, it's going to be less steep. So if something is less steep, it's going to be wider. And for us to figure out where the new points are going to be, we just take the y-coordinate, guys, and they're just going to be multiplied, so being multiplied by that number A. And the last transformation is a vertical reflection. And we have to know that we are going to reflect every point that's on our graph over the x-axis. So let's just draw out an actual just sketch, and we know which of these is going to be our x-axis. So let's just draw in something that looks like this, which wouldn't pass a function test because hopefully you tell me it doesn't pass the vertical line test. But that's the x-axis, so when we flip it over, that's reflecting, right? Okay. So example 1 says to describe the transformations of the following functions given the parent function of f of x. So I'm giving you a random parent function. As you notice, they're all f of x. And now I just added 1 or 2 or all 3 of those transformations to these, okay? So I'm looking at the top one, and I noticed a minus 5. This is at the end, right? So if I look back up here, anything happening at the end is going to be a vertical translation. Let's go blue. So we have a vertical translation. If you want to use the word shift, that's fine. So vertical shift, and then you have to tell me which way am I shifting, up or down. Because I'm a minus 5, we're going to say down 5. Make sure that you tell us which direction, okay? All right, the next one, I realized that it's in the front. So what happens when you're in the front? You stretch in the beginning of your day. So now this is a vertical stretch, and then we say of how much? So of 3. Very good. All right, the next one is kind of lonely. All it has is this negative in the front. So the negative part tells us it's a vertical reflection. And I'm going to say over X axis. Awesome. The next one doesn't have a negative. It has that fraction. That fraction is in the front, in the beginning. We stretch in the beginning of our day. So it's a vertical stretch of 5/2. Awesome. Ooh, got a couple things going on here. So I have no negative. I have something in the beginning. So I'm going to start with a vertical stretch of 2/3. So we tackled that, comma, and then I had something at the end, right? So at the end, they're not stretches, they are vertical shifts, and it's at a +1, so up 1. Remember, vertical is up and down, no left and right, guys. Okay, the last one. So there is no negative. Awesome. I begin with something in front, so that means I have a vertical stretch of 2. Perfect. And then I had something at the end, a +4, so those are my shift. So a vertical shift up 4. Fantastic. All right, so after that, we can represent a function 4 different ways, guys. 1, we can go into a table. 2, we can represent it in a graph. Okay. 3, it could be an equation. And lastly, I can just use my words. So let's go in order then. I have this graph, okay, and this was given, and we're just going to say that this is our f of x, and we're going to say I want to shift this up 2. So it looks like here's my dot. I'm going to take that dot on the y-axis and I'm going to shift it 2. Now let's make it 3 so it's more noticeable. 1, 2, 3. So it jumped up, and now I'm going to draw a straight line all the way off my graph, arrows at the end, and now I'm showing that I shifted it up 3. So let's go into our equation. We got to name it a different way, right? We can't say f of x because the given one, we started with f of x, so let's just make up one. G of x is probably the most popular one, but it really doesn't matter. And I want to say that I took that original f of x and I shifted it up. So a shift is not in the beginning. Those are stretches. It doesn't have a negative, right? A shift is in the back. So I went up 3. So that's how we represent it as an equation. And in words, literally what we just do, how we wrote up above here all of the words. So we are going to say that this was a vertical shift up 3. Awesome. All right, let's flippity flip flop floop to the next page. Given the parent graph f of x, so all of those are parent graphs of f of x, the dash ones, perform or describe the following transformations. Okay, so parent graph is given, and now we have the words here. So let's begin. I want a vertical shift up 2. So I'm going to start by graphing. Here's my dot, move it up, and best of my ability, I'm going to draw the same, just that I moved it up. So then I say g of x is equal to, the original dash was f of x, and I did a vertical shift up 2, so plus 2 at the end, right? Now my range. So we have talked about range. I'm going to change this color. Remember, range is from bottom to top. So if I take this guy, I'm scanning it, scanning it, scanning it, scanning it, nothing, 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 nothing. Finally, I hit it right there. That height is at 2. I keep going up, 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 and I end on arrows that are pointing upwards, up to the infinity. So my range then is, whoopsie, sorry, from a 2 to infinity. All right, next one says I have a vertical stretch of half. So they nicely already graphed it for us. Remember, if it's less than 1, right, a fraction that is less than 1, 0 to 1, it's going to get not narrow, wider, right? So now let's just write out g of x. We have f of x, and we know that stretches are in the front. And then my range, if I'm reading it, the lowest point is at 0, and it's pointing up. And the last one now. Ooh, they gave us the equation. Okay, so a couple things I realized here. I got a negative on the front. So what does that mean? That means there's a reflection. And that reflection is over the x-axis. We got to be specific. Then I have a -1. What does that mean? That means that I have a vertical shift, tell me my direction, down 1. So now let's actually graph this the way we're supposed to. So first off, we're going to reflect this guy. So I'm going to start off with the purple. When I reflect, it has to reflect over the x-axis. So it's like as if we're folding it on that. Best of my ability, I made it kind of the same shape. But now it says that I still have to shift down. So I'm going to move that purple dot once down, and now I'm going to draw in my final parabola. And I'm going to say that the red is the final answer. If you don't use different color on any assessment or homework, then maybe make the first one, the one that I reflected, as a dash line, and then the solid one would be your final answer. All right, now we got to hit the range up. So it looks like we have arrows pointing down. Down means negative infinity. And if I keep scanning up, the highest point of that quadratic is at -1. Remember, bracket. Awesome. And then we just have 3 more guys. This is nice. So the dash ones are going to be our parent functions, and then the solid ones are going to be after the transformations, and we have to figure out what happened. So at this one, we have 2 ways. We can look at the graph, or I can just look at the actual equation. If I look at that, changing that to words, I notice that there's a +2 at the end. So that means that's a vertical shift. Which direction? Up 2. Awesome. Okay, and then I can look at my graph. I want to make sure, yeah, it definitely went up 2. That makes sense. And now I need my range. So remember, range has these asymptote lines that are never gonna ever pass it. So that curve will never hit that line. And that purple line is at a height of 2. And that curve is above it. So that means it's gonna go to infinity. And remember, exponential functions never have brackets. All right, the next one, we have to only just look at the graph. So first off, I'm going to go in and draw in my asymptote line. So it's never going to pass that. All I'm doing is I'm going to be looking at this curve, because that's the transformation curve. So it started originally on top. So what definitely happened if it ended up in the bottom? There had been a reflection. So we have a reflection over x-axis. And it doesn't look like it shifted apart, because if I look really closely here, guys, I'm going to do it in green. This was 1 box away from the asymptote line, and so is this one. So it looks like it just got reflected. And now my range. So we're looking at the yellow curve, and looking at the yellow curve, I have everything below, right? So below represents negative infinity, arrow pointing down, and the highest point is that asymptote line, which is 0. Okay, and the last one. Ooh, the last one, they're just giving us words. We got this though. So it says a vertical stretch of 2. So if I look back up on my notes at the top, it said stretches are in the beginning. So I'm going to first off, let's just write out our new function. So originally that dash is f of x, right? If you want, you can label it. And a stretch is in the beginning, so I'm going to put that 2 in the beginning. And now I have to stretch it. So if I'm stretching it and it's bigger, the number, the a, is bigger than 1, that means it's going to get steeper. Okay? So for me to make this steeper, it's like I have to make it half-ass steep, okay? So that's like half the distance to make it double the steepness. Goes out like that. Drawn my asymptote line. I know it's never going to cross that line, which means then it's above that line. That line is at 0, and it's pointing upwards to infinity. Remember, no brackets. All right, guys, this is the end. I would give you some advice, though. Go into Desmos, okay? Go into Desmos, put in an equation, y equals x right there. Then my next line, maybe do what happens when I do negative x. Oh, okay. What happens then when I have x and I have something at the end, plus 3? It went up 3. What happens when I have x or a number in front of x? Let's say 2. Comparing it to the original one, yeah, I got steeper, okay? So play around in Desmos with the different types of transformations. That's definitely going to help you out. All right, guys, great work. Keep it up. Keep advocating for yourself.